students, this lesson is for September 3rd, which is going to be Wednesday when you get back from your Labor Day holiday. So it's going to be quite a few days in between when you watch this. So you probably want to watch it probably like Monday or Tuesday before we come to class on Wednesday. Today we're going to learn how to write expressions from patterns. Back in middle school you did a lot with picture patterns and number patterns, but now we're going to really learn how to write some function rules that will define those patterns. Alright, so the 3 steps are listed right up here for how to come up with these function rules. You're going to begin with the constant or the starting amount. So we're going to always try to find out what goes with 0. Where does this thing start at? Okay? After we find out what it starts with, we're going to try to find what's called the rate of change. The rate of change is the differences of each side divided. So we have a little formula here that's going to help us figure that out. And then when we write our function rule, we put our rate of change with an x beside it, and then we add or subtract our starting amount depending on whether it's a positive or negative. So let's go to the work and start working some of these. So our starting amount in this one at 0, we're at 0. So our starting amount is 0. To get our rate of change, we find the rate of change on the right hand side. From 0 to 4 is a positive 4, and from 0 to 1 is a positive 1. To do our rate of change, we take the change in y, the difference in y, which is this side, divided by this side. So it's 4 over 1, which is 4. When we go to write our expression, we take the rate of change, which is 4, right here. We put an x beside it, and then we add the starting amount. 4x plus 0 would be just 4x, because we wouldn't write the 0 because it's not really there since it's 0. Number 2, identify our starting point. 0 goes with 9, so that's our starting amount. Our rate of change is found by looking at the differences over here. From 9 to 6 is down 3. From 0 to 2 is up 2. So our rate of change is down 3 over 2. If this could be simplified, we would simplify it, but it cannot be simplified. You learned how to simplify fractions back in middle school, and negative 3 over 2 or 3 over 2 is simplified. So our rule, we take our rate of change, put an x beside it, and then we add our starting amount. So negative 3 over 2x plus 9. This is our rule. Again, we have our starting amount right here, 10. Our rate of change, this is going down 2. This is going up 4. So our rate of change is down 2 over 4. This actually is reducible. 2 goes into 2 one time. Let's see, I'm going to carry it down here. So I'm going to divide both of them by 2. 2 goes into negative 2 and makes negative 1. 2 goes into 4, and so that's negative 1/2. So this is our rate of change with an x beside it, and we add our starting amount. This section teaches us what to do if the starting amount is missing. Back in middle school, you learned how to use a process column, and this will help you find out that starting amount if you want to, and then I'm going to show you a second way as well. The process column is how do we get from 2 to 8. Okay, and so we do our process column by finding our rate of change first. So we go, that is plus 2, that is plus 2, so our rate of change is 2 over 2, or 1. Then we start to fill in our process column. We take our rate of change, which is 1, we multiply it by our input, our x, and then we ask ourselves, is 1 times 2, does that equal 8? And obviously the answer is no. 1 times 2 is 2. So what do we have to add or subtract to 2 to get to 8? And the answer is 6. This 6 has to work for everything in the chart for it to be the starting amount. So we try it again here. 1 times 4 plus 6. 4 plus 6 is 10. 1 times 6 plus 6 is 12. 1 times 8 plus 6 is 14. So our starting amount is 6. So our expression is 1 is our rate of change, x plus 6, or we would drop the 1 in algebra and just do x plus 6. Okay. The second way to get the starting amount is to go backwards in the table. Right here we're at 2. To get to 0, we would go back 2 spaces, and we would get to 0. So here we're going to go back 2 spaces, and we would get to 6. And so that's another way to identify your starting point. Number 5 is a series of numbers or a sequence of numbers, and so it looks like you just have 1, 2, 3, 4 numbers here, but we've got to fill out this whole chart based on this. So what you have to do is you have to add in your own numbers here. 8 is the first number in the sequence. 5 is the second number in the sequence. 2 is the third number in the sequence. And 4 is the fourth number in the sequence. The number or term goes over here in your x's, 1, 2, 3, 4. And the output is your series, which is 8, 5, 2, and -1. Okay. Let's think it'll be easier just to go backwards to 0. That's 1 unit backwards to 0. So if we go 1 unit backwards here, over here on this side, it's going by 3s. So we're going to go up 3 to 11, and that's our starting amount, 11. To me, that's a lot faster than doing the process column, but the process column could show up on your test, so that's why we went ahead and showed it to you. Now we want to do our rate of change. From 8 to 5 is down 3. From 1 to 2 is up 2. Up 1. So our rate of change is -3/1, which is just -3. So our rule becomes -3x plus 11. Alright, down here it says making connections. How can we check to see if the rule is correct? Okay. So what we would need to do is check to see, do these numbers, when they're plugged into here, produce these numbers over here? So I would take the rule, -3, I would plug in my 1, I would add 11 to it, and I'm basically asking myself, question mark, does this equal 8? So -3 times 1 is -3, plus 11, does that equal 8? -3 plus 11 is 8 equals 8, and so it does work. And you could try that for all of the numbers in there and make sure they work. All right, now we get some word problem. It says that Raymond bought a scooter for $600. It will cost him $300 a year for gas. The total cost of the scooter depends on the number of years he owns it. Fill in the table and write an expression to represent the total cost of owning the scooter after n years. Okay? So at 0 years, when he first got it, how much did the scooter cost? I go back to here. Raymond bought the scooter for $600. It will cost him $300 a year. So after 1 year, it's going to cost him $300 more, which gets us to $900. Then you got to be careful here because it jumps all the way up to 4. So in 4 years, so it's missing steps 2 and 3 out of the table. So 2 would have been 300 more, so that's 1200. 3 would have been 300 more, which is 1500. And then that would make step 4 1800. And then you're missing 5. 5 would have gone up 300 more, which would have been 2100. And then 6 would go up 300 more, which would be 2400. Alright, so when we go to write our rule, we've got our starting amount. We'll look for our rate of change. This goes up 300. This goes up 1. So our rate of change is 300 over 1, which is 300. So our rate of change is 300 times our x plus our starting value is 300x plus 600. And these numbers are represented here. We could have done this without the table, but we were just showing you how you could work backwards through the table. Alright, here we have a picture pattern. It says the relationship between the figure independent and the total number of square tiles dependent is a function. Okay? Some other words we want to start to introduce. This column over here is known as the domain. This column over here is known as the range, and we'll study a lot more about these words later on in the year, but domain and range are important words. Domain is the first column, which is your x, and the range is the second column, which is your y. Okay. So we're supposed to be figuring out how many square tiles are used. So there's 1 tile in this first picture. In the second picture, there's 1, 2, 3 tiles. And in the third picture, there's 1, 2, 3, 4, 5 tiles. Now we're going to work towards a rule. Let's go backwards and find the 0. So that's going back 1. This one, since this goes up 2, we're going to go back 2, which would be subtracting 2 to -1. So that's our starting amount. Our rate of change can be found by doing that's up 2, that's up 1. So our rate is 2 over 1, or 2. So this is 2x plus oops, let's get rid of, I got a little too fast for myself there. It's actually not plus this time, because our starting point is a minus 1, it's 2x minus 1. If we were to graph this, we would do our domain, or our x along the bottom, so this is figure number, and we would do our range along the side here. This is number of tiles. My numbers are pretty small here, so we could just do 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, over 1, up 1, over 2, up 3, and over 3, up 5. And we see that this has a positive correlation from the other day. These lines are going up in the air. Another picture pattern here, we're worried about perimeter, and each side has a measure of 1, so this is 1, 1, 1. So the perimeter of the first one is 1 plus 1 plus 1, or 3. This is 1, 1, 1, 1, so the perimeter of this one is 1, 2, 3, 4. The perimeter of this one is 1, 1, 1, 1, 1, which is 1, 2, 3, 4, 5. And I think at that point you can start to see the pattern, 3, 4, 5, 6, 7. Let's go backwards and find the 0 one. This is going up by 1, so this is going to go back 1 and be 2. So we can go anywhere on here and do our rate of change. That's plus 1. That's plus 1. So our rate is 1x. Plus our starting point is 2. And remember, we drop the 1 and just get x plus 2. In this case, this is our domain, or our independent. This is our range, or dependent. Over 1, up 3. Over 2, up 4. Over 3, up 5, and over 4, up 6, and over 5, up 7. And so again, you can see that makes a positive correlation as well. What would be the perimeter of figure 10? So we could do two things. We could plug this 10 in here, it'd be the fastest thing. 10 plus 2 is 12. Or we can continue our pattern out to that and figure it out that way. As far as letter E for 35, I wouldn't continue my pattern out that far because it would take too long. 35 plus 2 is 37.